Hello friends, welcome to all to my video lecture of subject Basic of Mathematics. Topic of today's lecture is roots of polynomial. How to find out the roots of polynomial. So I am Mrs. Koite Gauri, Assistant Professor in First Year Department, BPKBIT Panama. So many times we are dealing with the roots of polynomials and we have to find out the accurate root. In higher education, suppose for engineering, to find out the solution of linear differential equation, we have to find out roots of auxiliary equation, or in many cases, we have to find out extreme values, that means maximum and minimum value of polynomials. Again, we are dealing with the roots of polynomials. Also, in many competitive exams, we have to find out the roots of polynomials without calculator. In many competitive exam, calculator is not allowed. So in this video lecture, we revise how to find out the roots of quadratic and cubic polynomial. So let us revise it. So what is polynomial? So general polynomial of degree n is given as p of x is a0 x raised to n plus a1 x raised to n minus 1 plus a2 x raised to n minus 2 plus so on an minus 1x plus an is equal to 0. This is the equation of degree n, where this a0, a1, an are all real constant numbers. Okay. So here it is nth degree polynomial. So let us see example. 2x square plus 3x plus 5 is equal to 0. It is second degree polynomial. Another example, x cube minus 1 is equal to 0. It is the cubic polynomial. Okay. So first we see what are the roots of polynomial. The roots of polynomial is the value of variable x which satisfies the given equation or given polynomial. So simple example, when I put x minus 3 is equal to 0, this is my simple polynomial. When I put x is equal to 3, it satisfies the equation and therefore root is x is equal. Similarly, for x plus 5 is 0. If I put x is minus 5 here, minus 5 plus 5 is 0. So x is equal to minus 5 is root. So another example, suppose x square minus 5x plus 6 is 0. This is my polynomial p of x. So we try to find out the root. So first I put suppose x equal to 1, then 2 and 3 like this. So when I put x is 1, what I am having? 1 square, that is 1, minus 5 times 1, so it is 5, plus 6. So here it is 6 plus 1, 7 minus 5, it is 2, and it is non-zero number, and therefore x is equal to 1 is not a root. Now let us try for 2. So 2 square means 4, then minus 5 times 2, 5 times 2, 5 into 2, and then plus 6. So when I simplify this, so 4 plus 6, it becomes 10, and 5 into 2, it is again 10. So 10 minus 10 is 0, and therefore x is equal to 2, satisfy this polynomial. So this is the root. Similarly, you can check for 3 also, and we get 2 and 3 are the roots. Okay. So let us see another example. X square minus 2 is equal to 0. So if you put root 2 or minus root 2, it satisfies the equation. So therefore, this is the roots of given polynomial. Another example, x square plus 1 is equal to 0. So what are the roots? Here, x square plus 1 is equal to 0 means x square is equal to minus 6. And we know that square of every real number is positive. Therefore, real root is, there is no real root. But if I consider complex number, I is equal to root of minus 1. So therefore, I square become my root minus 1 square. So square root will get cancelled, it is minus 1 square. I satisfy this equation. Similarly, minus I also satisfy this equation. So in this way we get 2. But now each time we cannot trial and error. So there are some techniques we already learned in school algebra also to find out the roots of these such polynomials. Okay. So we see first properties of this polynomial. So every polynomial of degree n has n roots. Second property, roots of polynomials are either rational, irrational or complex numbers. So we see in previous example 2, 3 are roots, then minus 5 is also root, then root 2 minus root 2, that means irrational numbers are roots, and I is complex number which is also root. So roots may be rational, irrational or complex number. Then some polynomial having repeated roots also, some having distinct. Root may be distinct or repeated. Then fourth property is complex roots always occurs with conjugate pairs. So it is very important property. So if 1 plus I, what does it mean? If 1 plus I is the root, then definitely 1 minus I is the root. So conjugate of this complex number is also the root. Okay. So therefore, complex roots are always occurs with the conjugate pair, and therefore it is corresponding to degree greater than 1, that is greater than 2. And if we having odd degree polynomial, so it has always at least one real root, because complex roots are always occurs with conjugate pair, so it is multiple of 2. So therefore odd degree polynomial has at least one real root, and therefore cubic polynomial, if we consider, it also has one real root. Now we see different methods for finding the roots of polynomials. So first is factorization, second using standard formula for quadratic equation, then third synthetic division method for finding cubic and higher degree polynomial, and fourth one by using substitution or rearrangement of the term, sometimes using the standard formula, and last one you can use calculator and you can find out the roots of polynomial. Okay. So first we see factorization. So we know if x minus a is the factor, then corresponding root is x is equal to. Similarly, if x plus a is equal to 0, I take this plus a to RHS, x become minus a. So therefore, root corresponding to x plus a factor is x is equal to minus a, and root corresponding to x minus a factor is x is equal to 2. Then ax plus b is 0. So I shift b to RHS, it become minus b. Then ax is minus b, divided by a, so x become minus b by a. Okay. So these are some examples I discussed. X plus 5 is 0 means minus 5 is root. X minus a, that is a is 1, so x is equal to 1 is root. 2x minus 3 is 0. So 2x is equal to 3, x becomes 3 by 3. Similarly, you can find out for fourth one. So these are the linear factors, and you can find out the roots. Now quadratic equation also we can write in terms of linear factors. So x square minus 5x plus 6, I rearrange this minus 5x as minus 3x minus 2x, and then we are taking first x outside, where we get x minus 3. Again I take minus 2 outside, x minus 3, and then we having the factors are x minus 2, x minus 3. So here it is of this type, the roots are 2 and 3. Similarly, for x square minus 9, so x minus 3, x plus 3 are the factors, and roots are plus 3 minus. So in this way you can find out factors. But each time it is not easy to find out the factors of such polynomial. At that time we are using standard result. Okay. Now, next we see some formulas and their roots. So, we already see this in school algebra, but just revise it. So, d square minus a square, factor of this quadratic equation is d minus a, d plus a, and roots are a minus. But if it is d square plus a square, then factors are d minus ai, d plus ai, a rise complex number, and roots are ai minus ai. Then d cube minus 2a d plus a square. This is the expansion of d minus a square. And if I equate it to 0, I get d minus 1 is 0, d minus 1 is 0. So root a is equal to d is equal to a. It occurs 2 times. So roots are repeated. Okay. Similarly for d plus a bracket square, roots are minus a minus. Now d cube minus a cube, factors of this is d minus a first factor, and second quadratic factor is d square plus ad plus s. Then d cube plus a cube, first factor is d plus a, and another factor is d square minus ad plus s. Okay. Then the expansion of d plus a bracket cube is d cube plus 3ad square plus 3a square d plus a cube. So if such expansion is there, and if you observe a and this type of coefficient, so we can write it in the terms of d plus a cube, and the roots are d plus a is 0 means d is equal to a, and factor occurs 3 times, so roots repeated 3 times. So roots occurs. Similarly for d minus d cube minus 3ad square plus 3a square d minus a cube. This is the expansion of d minus a bracket cube, and therefore d minus a is factor, so roots is d is equal to a, and it occurs 3 times, so roots occurs 3 times. Now fourth degree, d raised to 4 minus a raised to 4, we can write d square square minus a square square, and using this factor d square minus a square is d minus a d plus a, we can write this term is d square plus a square d square minus. And by using these first two, the roots of first term is ai minus ai, root of second factor is a and minus. So in this way, by using this standard results, we can find out this. Now we see, or I revise instead of learning, revise the basic formula for finding the roots of quadratic equation. So quadratic equation, we know it is given as ax square plus bx plus c is equal to 0. That is a, b, c are of coefficients and this constant term. Then the root of this quadratic equation is given by the formula x is equal to minus b plus minus square root of b square minus 4ac upon 2a. Okay, so for any type of quadratic equation, roots are, we can calculate the roots by using the formula. I recall x is equal to minus b plus minus square root of b square minus 4ac upon 2a. Now depending upon this term square root of b square minus 4ac, which is called as discriminant delta, our nature of root is depend. So if this term square root of b square minus 4ac, or if b square minus 4ac term is positive, then we having real roots. If this term b square minus 4ac is negative, then we having complex roots and which are conjugate of each other. And if this term b square minus 4ac is 0, so we have repeated roots minus b upon a. So now we see relation between roots and its coefficient. So what are the relations? So if alpha and beta are roots of quadratic equation x square plus bx plus c is 0, where a, b, c are constants, then the relation between roots and coefficients is alpha plus beta is equal to minus b by a. That means sum of the roots is minus b by a, and alpha into beta is c upon a. So you can see the example. My polynomial is x square minus 5x plus 6 is 0. So value of a is 1, b is minus 5, c is 6. So if you find out roots by using previous formula, 2 and 3 are the roots. So what are the sum of the roots? 2 plus 3, 5, which is same as minus b by a, minus 5 upon minus times minus 5 by 1, that is 5, and product of the root is 6, and c by a is also. Okay. Now we see examples. Find the roots of polynomial x square minus 5x minus 6 is equal to 0. So always we compare with the standard result ax square plus bx plus c is 0. So here what we are getting, a is equal to 1, b is equal to minus 5 and c is equal to minus. So we use the formula x is equal to minus b plus minus square root b square minus 4ac upon 2a. So my value of b is minus 5. So minus times minus 5 plus minus square root of b square 25 minus 4 times. So minus times minus 5 plus minus square root. B is 5, so b square is 25 minus 4. A is 1, c is minus 6 upon 2a. So a is 1. So when I simplify this, I get 5 plus minus square root of this 6 minus minus plus 24 plus 25, 49, and root of 49 is 7. So x is equal to 5 plus 7 by 2 or 5 minus 7 by 2. That is x is equal to 12 by 2, which is 6, or minus 2 by 2, which is minus 1. In this way we get the roots. Another example, x square plus 2x plus 2 is equal to 0. Then here again I compare the standard equation. A is 1, b is 2, c is 2. So again we use the standard formula for finding roots. X is minus b plus minus square root of b square minus 4ac upon 2a. So here I substitute the value. I get here minus 2 plus minus. Here b square minus 4ac we are getting minus 4 after calculation. And minus 4 how we write now? So minus 4 we can write root of minus 4 is equal to root 4 into root of minus 1. So root of 4 means 2 and root of minus 1 is I. So in this way here we get it is 2i. So minus 2 plus minus 2i upon 2. So when this value is negative, we get complex part or imaginary value. And then when I take one time plus sign, so minus 2 plus 2i by 2, that is minus 1 plus I, and minus 1 minus I, that is roots. And you can see here they are the conjugate of each other. Okay. So here we get complex roots. Now let us see third example. X square minus 4x plus 4 is 0. So here a is 1, b is minus 4, and c is 4. Okay. So x is become my formula minus b. So here minus times minus 4 plus minus square root b square. So minus 4 square is 16 minus 4 times a is 1, c is 4 upon 2 into a. So 2, a is 1. So minus minus plus 4 plus minus. This 16 minus 4 into 4, 16. 16 minus 16, 0. So 4 plus minus 0 by 2. So 4 plus 0 by 2 means 2. 4 minus 0 by 2 is 2. So here we are getting 2 are repeated roots when delta is 0. Another way, this is the expansion of bracket x minus 2 square is 0. So factor is x minus 2 that occur 2 times. So roots are x is equal to 2. So anyway, you get same roots. Okay. So let us see another example. 2x square minus x minus 10 is 0. So here a is 2, b is minus 1, a is minus 10. So when I substitute, we get such roots, fraction types, y by 2 minus 2. Okay. So we get any type of roots by using this formula. Okay. Now we see roots of cubic polynomial. So for cubic polynomial, general cubic polynomial is ax cubed plus bx square plus cx plus d is 0, where a, b and d are constants. So we know that for odd degree there is one real root. Here also we can find one real root. And to find out the remaining roots, we are using synthetic division. So what are the steps? So step 1, we are finding one root by using trial and error method. And the root is mostly the divisors of constant points. For trial error, we use divisor constant point. So after finding one root, we are using synthetic division method to find out the quadratic factor, and then we are finding the roots of quadratic factor, and then we get root of this cubic polynomial or expansion is one linear term, another is quadratic factor, and root of all these two get all the roots of cubic. So example, find the root of x cube minus x square plus 4x minus 4 is 0. It is a cubic polynomial, and if we compare this, we get a is 1, b is minus 1, c is 4, d is minus 4. Now, to find out the other quadratic factor, we have to find out first root by trial error. So we check for divisors of 4. So we take plus minus 1, plus minus 2, plus minus. So I try for x is equal to 1 first, the root. So when I put x is 1 minus 1, then plus 4 minus 4. So 0 we are getting, and therefore x is equal to 1, satisfies the given equation. Okay. Now, if we get one root, no need to find out remaining roots. We have to find out only one root, and we are finding remaining factors using synthetic division. So in synthetic division, first we write the first row is after this line the coefficients of the x cube, x square, x and constant term like this. So here coefficient of x cube is 1, x square is minus 1, x is 4 and constant term is minus 1. Now whatever having root x is equal to 1, we write here the root 1 and we put here dash and we carry this one as it is. Then 1 into 1, 1. So here we add this number minus 1 plus 1, so it is 0. We are getting then 0 into 1, 0. Then 4 plus 1, 4. And then 4 into 1 again, 4. So minus 4 plus 4. So in this way, we are getting here the factors, and in here, if we get last number is 0 means our root is correct, and this is the required quadratic factor. So how we write x cube minus x square plus 4x minus 4? First linear factor corresponding to root x is equal to 1 is x minus 1, not x plus 1, x minus 1. And to write down quadratic factor, this is the coefficient of x square, this is the coefficient of x, and is constant. So 1x square plus 0x plus 4. This is the quadratic factor. That means x square plus 4. And we know the roots of x square plus 4 is x square plus 2 square. So it is of the type x square plus a square. And roots are plus a or minus a. And root corresponding to this factor is 1. So we get x is equal to 1 to 1 minus 5. That is root. So I hope you understand roots for finding cubic polynomial. First what we do, we are finding the one root by trial error method, x is equal to 1. Then to use synthetic division, in first row, first we write all the coefficients of cubic polynomial, and coefficients are in ascending order. Put dash here, take this one as it is, then 1 into 1, 1, take addition of this number 0, 0 into 1, 0, 4 plus 1, 4, 4 into 1, 4, minus 4 plus 4, 0. So last term must be 0. That means we confirm 1 is the root. This is synthetic division method. And another factor of this polynomial is x square plus 0x plus 4 is 2. So we are finding roots of this. We are getting all. Now similar example for finding cubic polynomial, x cube minus 7x minus 6 is 0. So here the cubic polynomial is there. So we are finding one root by trial error method. Constant term is 6. The divisors are plus minus 1, plus minus 2, plus minus 3, plus minus 6. Then we check for x is equal to 1. So 1 minus 7 minus 6. So it is not the root, x is equal to 1. So we get 1 minus 7 minus 6. So what we are getting? Minus 12. So it is not a non-zero. It does not satisfy. Now I go for x is equal to minus 1. So minus 1 cube is minus 1. Minus minus plus 7 minus 6. So what we get? Minus 7 plus 7 is 0. So here it is the root, x is equal to minus. Now we are finding another factor by using synthetic division. So first I write coefficient of x cube is 1. Then 0x square. So 0x square. No term of x square means we write 0x square minus 7x. So coefficient is 7 minus 6. So here it is minus 6. Now root is minus 1. So I write here. Now what we do? I take this dash as it is. So 1 carry as it is. Carry this 1. Then 1 into minus 1. Minus 1. Add these two numbers. 0 plus minus 1. Minus 1. Minus 1 minus 1. Plus 1. Minus 6 plus 1. Minus 6. Minus 6 into minus 1. Plus 6. So we get last term is 0. And quadratic factor is x square minus x minus. So x square minus 6 minus x minus 6. And factor corresponding to root x is minus 1 is x plus 1. So factors of the cubic polynomial is x plus 1, x square minus x minus 6. And now find out another two factor or directly roots. So we are getting x is equal to minus 1 minus 2 and plus 3 vidagi. Okay. So similar, you try for this. Another way you can use substitution or rearrangement. It is a cubic polynomial, but here it is x. So we can take x outside immediately and I get factor. So instead of synthetic division, immediately we can find out the root. So x is equal to 0 is root and x square plus 4 is 0 means x square plus 2 square is 0. So y minus 1. Another term x cube minus x square plus 4x minus 4 is equal to 0. So here you can take something is common. In second two term 4 is common. First two term x square is common. So when I take x square common, x minus 1 is remaining. Next two terms when I take 4 common, x minus 1. Again I take x minus 1 outside. What is remaining? X square plus 4. And I can find out roots of this is x square plus 4 means 2y minus 2y. X minus 1 is root. Corresponding root is x equal to 1. Okay. So for cubic polynomial, sometimes we can rearrange term and we can easily find out the factors and we can find out the roots. Now suppose if it is x raised to 4 minus 16, 4th degree polynomial. So I can write x raised to 4 is t, sorry, x square is t. So x square means x raised to 4 becomes t square, and my given polynomial is reduced to t square minus 16 is 0. So t square minus 4 square is 0, t is 4, t is minus. So t is x square, so x square is 4, x square is equal to minus 4. So x square minus 4 is 0, means x is 2 minus 2. X square is equal to minus 4, means x is 2y, x is minus 2. Another factor, x raised to 4 polynomial plus 6x square plus 9x. So here all even polynomial, even coefficients, and I can use x square is equal to t. So this polynomial reduced to x raised to 4 is t square plus 6t plus 9x, which is quadratic. And by our previous method, finding roots of quadratic equation minus b plus minus b square minus 4ac upon 2a, you get the roots of this polynomial. So here roots are minus 3, repeated roots. But t is x square. So x square is minus 3, means x square plus 3 is 0. And again, root of this is root of 3i minus root 3i. And it is repeated. So roots root 3i, root 3 minus root 3i also repeated. So in this way, sometimes by using substitution, rearrangement, we convert it into quadratic equation or we find out quadratic factor and we can find out the roots. Okay. So my video is there. I will share the link of how to calculate the roots using calculator in message box. So you go through that link and you can know how to find out the roots of quadratic and cubic polynomial by using scientific calculator. Sometimes we are dealing with higher degree polynomial. So at that time we have to use some mathematical software or we can find out online solution for this. Many websites like Polynomial Root Finder or another websites are available on Google. So for fourth order or higher order, you can find out the roots by using ANA. So thank you so much. I hope you like this video. So like my channel and subscribe also my channel. You can find out more videos on basics of mathematics like derivative and integration. So thank you.